So let's take a look at some of these here, and it's the same things, my friends. It does not change. Let's do this. Notice they're multiplying. What the heck? I'll use a prog rule. Let me label this whole thing first and this second. So what are we going to do? Well, my friends, we're going to take the derivative of the first, which is negative 8x to the third, multiplied by the second. Leave the second alone. Plus, we're going to leave the first alone. Now take the derivative of the second. Boom. There it is. Done. Okay, in class, we're going to simplify this out, but right now we're just getting practice on how to do this. Take the derivative over here. We'll label this to be first. And this second. Okay, so take the derivative of the first, 8x to the third, times, leave the second alone. Boom. Leave the first alone. Now take the derivative of the second, 2x, boom. There it is, done. Nothing else to be done. Think about how quick that is, my friends. That is so efficient. And in class, we'll learn how to distribute it out and simplify this. But really, this is calculus. You're done. Calculus is over. The simplification is all algebra 2. All right. I'll let these problems over here for you to do. I think you should be able to do this one pretty well. But why not? Let me go over number 6. So just because there's a negative exponent, we haven't done one in a minute. So take the derivative of the first. Well, I'll label this to be first, and this will be second. Okay, just to be consistent. The negative 3 disappears. I get negative 3x to the subtracting 1. That's negative 4. And now we're going to leave the second alone. Okay, plus we're going to leave the first alone. Boom. And I'll take the derivative of the second, which is negative 12x squared. Done. Okay, and that's pretty much it, my friends. All right, going over some maybe more challenging ones, or ones that could be a little challenging. Let's say we wanted to take the derivative of these. We'll notice how we're multiplying our functions here, right? Here I have the multiplication symbol, here I don't. Well, it stays the same. We'll just label the e to the x to be the first, and we'll label sine to be the second. Over here I'll label cosine to be the first, and I'll label e to the x to be the second. Okay, so let's go ahead and do this. We'll take the derivative of the first. Well, remember, we talked about this in class. The derivative of e to the x is just e to the x times, we'll leave the second alone, so we leave the second alone, plus leave the first alone, so we leave e to the x alone. What's the derivative of sine? Well, we get cosine of x. Boom. And there it is, my friends. There is our function. Let's go over here. Take the derivative of the first. It's negative sine of x. Okay, times leave the second alone, plus leave the first alone. Now take the derivative of the second. Well, derivative of e to the x is e to the x. Done. Nothing else to be done. Okay. Looking at these ones below here, we can go through them. I'll label this to be first. Boom. This will be second. Boom. Okay, this will be times sine of x. Okay, so why not label x just to be first and sine to be second, like such, okay? Take the derivative of the first. We're going to get 3 minus 4x. Leave the second alone. Plus, leave the first alone. Now, take the derivative of the second, which is just 4. Done. Nothing else to be done there, right? Just getting practice with this. Okay, take the derivative of the first. What's the derivative of x? Well, there's like an invisible 1 in front of x. And remember, this, if we take the derivative of 2x, it's just 2. Derivative of 3x is just going to become 3. If we take the derivative of these, so what's the derivative of just x or 1x? Well, we get 1. So we're going to get 1 times, leave the second alone, plus leave the first alone, multiplied by the derivative of sine, which is cosine of x. So we get sine of x plus x cosine of x. Boom, done. And there it is, my friends. Hopefully this is feeling pretty good. So just to add one little challenge problem, determine the equation to the line tangent. So essentially what we want to do is find, I'll make some random shape here. I see sines and I see square. I'm not sure how it looks, but let's just say it's something like something curvy, I guess. I don't know. But basically we want to find this tangent line here, right? Tangent line is the line that touches the boundary of your function. And we want to find the equation. Well, to find the equation, we need the slope and we need a point. And remember, because we're asking for the equation of the line tangent, we're going to write our point slope form because those are the necessary items that are needed. Do we have our points? Well, we have 0. Well, how do we get the y value? We'll plug in 0 into the function. So we'll get sine of 0. So y is equal to times the square root of 0. Can we get y is equal to, well, even if you didn't know what sine of 0 was, what's the square root of 0? It's 0. And what's 0 times anything? We get 0. So we know for a fact then, okay, I'll write it over here, that my x value is 0, my y value is 0. Boom. All right, awesome. So I can plug these in. Y minus 0 is equal to m x minus 0. What's left to find is your slope. Well, how can we find the slope? Well, slope, that instant slope, will be given to us by taking the derivative of this function. And notice how we have two functions multiplying. We're going to have to use the product rule. So what's the derivative of sine? Well, my friends, that is cosine. Leave the second function alone, plus leave the first alone, which is sine. And now we need to take the derivative of the second function, which we can call square root of x. So remember, square root of x is the same thing as x to the 1/2. Taking the derivative of this, I'll write it over in the corner, bring the 1/2 down, so we get 1/2 x to the, subtract by 1, but we'll do it in a fancy way, 2 over 2, so we get negative 1/2. The negative means that we're going to divide. Notice there's already a division sign, so it's just 1 over 2x to the 1/2. So we'll write it over here, 1 over 2x to the 1/2. Rewriting this, I'll write it over here. We could write it in a nice kind of organized way, square root of x times cosine of x. Okay, oops, I drew that x kind of weird. Plus, right, the sine of x and the 1 are on top. This is the only thing on the bottom, so we'll write sine of x over 2x to the 1/2. And now all we're going to do is plug in 0 into this function to get our slope. So if we plug in 0 to the square root of x, what's square root of 0? 0. So this is gone. Sine of 0, well, my friends, believe it or not, oh, we're going to have a problem here because we're going to get 0 over 0. All right, this is going to actually be 0, and we actually get 2 times 0 to the 1/2, and this is an issue, okay? And this will most likely mean our derivative does not exist, that we actually can't even make this possible. So we'll take a look at a graph of that, and we'll try to understand why.